everyone. I am Dr. V. Amirthavalli, Associate Professor from the Department of Petroleum Engineering. In today's session, we are going to see about the phase diagram for reservoir fluids. A phase diagram, which is nothing but the experimental or mathematical determination of the conditions like the composition of the hydrocarbon mixture, the initial reservoir pressure and the reservoir temperature, can be expressed with the help of different types of diagrams called the phase diagrams. What is the need to study the phase diagram? The phase diagram has importance in various, that is in natural gas as well as in petroleum engineering. The pressure, volume and temperature relations are very much required in simulating the reservoirs, in evaluating the reserves, forecasting the production, designing the production facilities as well as in designing, gathering and your transportation systems. What is a reservoir? Reservoir is a porous, underpermeable, underground formation which contains a lack of hydrocarbons which will be confined by an impermeable rock or a water barriers, and it will be characterized by a natural pressure systems. And we can classify, now we have seen what is a reservoir. Then we can classify the reservoir based on the two types, that is based on the critical temperature you can classify the reservoir, or based on the bubble point pressure. Based on the critical temperature, we can classify the reservoir as oil reservoirs or gas reservoirs. Oil reservoir, if the initial, that is your reservoir temperature, is less than the critical temperature of the reservoir fluid, the reservoir is classified as an oil reservoir. Then what is a gas reservoir? If the reservoir temperature is greater than the critical temperature of the hydrocarbon fluid or your reservoir fluid, then the reservoir is classified as a gas reservoir. We can still further subclassify the oil reservoir based on the reservoir pressure. So it will be classified as undersaturated oil reservoir, saturated oil reservoir and a gas cap reservoir. Undersaturated oil reservoir. If your initial reservoir pressure is greater than the bubble point pressure of the reservoir, then the reservoir is classified as an undersaturated oil reservoir where it will exist in the phase of the liquid, that is oil. Saturated oil reservoir. When the initial reservoir pressure is equal to the bubble point pressure of the reservoir fluid, then the reservoir is classified as a saturated oil reservoir. A gas cap reservoir. If the reservoir pressure is below the bubble point pressure of the reservoir fluid, the reservoir is termed as a gas cap, where you can have it as a two-phase, that is oil as well as gas, in which the oil will be above your gas, or you can say that the gas is underlined by an oil phase. Next we will see the various types of phase diagrams. We can draw the phase diagram between pressure temperature, pressure volume, pressure composition also. In the first session we will see the pressure temperature phase diagram. Similarly, we can do the pressure temperature phase diagram for a single component system, for a two component system as well as for a multi-component system. In this session, we will see for a multi-component system. So, the multi-component pressure temperature diagrams are used to classify the reservoir. It will help you to classify the naturally occurring hydrocarbon systems as well as it will help you to describe the phase behavior of the reservoir fluid. Let us see the P versus T, that is pressure temperature diagram for a multi-component system. From this diagram, we should learn some of the important terminologies. First one we will see is called the Crichton term. What is the Crichton term? It is the maximum temperature above which you cannot have the liquid to be safe. So regardless of the pressures, that maximum temperature is called as the Crichton term. It will be represented by T suffix Ct, and the unit for the Crichton term will be your degree Kelvin, or you can say in terms of Rankine. Similarly, from the P versus T diagram, we can see Crichton bar. Crichton bar is the maximum pressure above which gas cannot be formed even though you change the temperature. That maximum pressure is called as a Crichton bar. The unit for the Crichton bar will be your bar. Then the last of this P versus T diagram, you can see the point C. C is called as the critical point. The critical point is a point at which you cannot distinguish whether it is a gas or a liquid, or you can say at this point the intrinsic properties of the gas and liquid are same. So the corresponding temperature to the critical point when you draw, it is called as a critical temperature, and the corresponding line if you draw to the y-axis and you name it as the critical pressure. The critical temperature, as we know, the unit for critical temperature will be the same as the unit of our temperature, and the critical pressure will be set in terms of bar. Then we can see in that diagram bubble point curve. What is that bubble point curve? The bubble point curve will be the line which separates the liquid from the two-phase region. Similarly, the dew point curve will be the line which separates the gas from the two-phase region. Now we will see what is this two-phase region. The phase envelope, they will say, or it is a two-phase region. It is nothing but the region which is enclosed between your bubble point curve and the dew point curve, where the liquid and the vapor coexist in equilibrium. And still more further, we can see that dotted lines are inside the two-phase region. Those dotted lines are called the quality lines. They say you how much amount of liquid and vapor is present. So in the case of a bubble point curve, we can say 100% liquid, only one bubble of gas will start to come. Next dotted line, we can see it is 90%, which means that 90% is liquid, remaining 10% is vapor. Similarly, it goes on 70%. So we will say that it is 70% of liquid, remaining 30% of vapor. All the quality lines will converge at the point C. That is your critical point. That is one information we should know. So we have seen all the terminologies which is concerned with the pressure temperature phase diagram. With this we will close today's session, and in the next session we will see the next part, that is we will learn about the how do we classify for oil reservoir, what are the types, that is you can say it is an ordinary black oil and low shrinkage oil, high shrinkage oil, and we will start learning how to draw the liquid shrinkage curve also. Thank you.